Alright, in this video we're going to cover how you might send frames kind of in a fuzzing type scenario where you know some of the bytes that you need to send, but you need to investigate your options for other bytes, or perhaps you know the general format but you need to output a range of values, say, in order to create counters and security bytes and things like that. So the easiest approach, we'll go to custom frames here. Let's say that you know that you need to send with ID 7E0. You're going to send 8 bytes. And you know that the first bytes need to be 2 and 31. And the rest of these will be 0. Just for those that are curious, this would be hexadecimal 31. This was kind of setting up for a UDS packet that would do routine control. So what we're kind of going to do here is fuzz sending a bunch of routine control messages to an ECU that may answer at 7E0 and see what it says. So we put our data bits in here. Our trigger, I'm going to say 100 ms, which means 100 milliseconds. We'll try 10 of these per second. For modifications here, let's move this out. You can see that there's count there now. For modifications, we'll put D2 equals D2 plus 1. They're counting starting at 0, so D0, D1, D2. So what we're going to do is try every combination of D2 here. We'll click enable, and you can see that we are sending on the bus now a sequential list of frames with that byte changing. So if you wonder what happens when you send on your car a routine control message just with a single byte, and what would happen with every single byte sequence that you could send, you can do that this way. So we're going through here. You can see that at the end we recycle back over. So you can use this to do some fairly powerful things. It won't let you make control bytes or like security bytes because you can't really do a lot here. You can do modifications here. I could have put another one, D3 equals D2 plus 3. I could change this to, say, 50 milliseconds. We'll go over here, clear that, re-enable, and now you can see that it did what I said. You can do a variety of things here, addition, subtraction, multiplication, and or XOR between bytes. This is a fairly powerful window. You can also make your trigger be when a message comes in, you trigger on that instead of just on a milliseconds. But this kind of gives you the general idea of how you could do some quick, simple tests with the custom frame sender in order to get some traffic out and see what happens. Pretty much the sky's the limit here for the data that you can send. You could send any length on any interval. Kind of change the bytes around with basic arithmetic. Like I said, it's not probably going to be sufficient for calculating security bytes, but for just general messages like this, if you wonder what happens if you send a certain number of bytes with various messages, you can pretty much just go through the list and find out what happens. So that's one option that you have for bus fuzzing. The next easiest one perhaps would be the actual fuzzing window. We can do the same thing here. We'll say that we want our frame time to be 50 milliseconds each time. We'll send 1 frame each time, 8 data bytes on bus 0. The ID scanning doesn't really matter because we're going to put in the exact same ID both times. Do the same thing here. Now this is exactly what it says down below. White bits are always 0. Green are going to be fuzzed by the bit scanning type down there. black bits are always set. So what we'll do here is, kind of clear these out. Now, as in the first example, we're pretty much going to show what happens if you try to fuzz various bytes. The first one was 2 for this message. So what we'll do is we'll come up here. In the future, I might put the actual hex value that the white and black bits form here to make it easier, but that's 2. So 1, 2, 4, 8, 16, 32, 64, 128. So in hex, the next value that we were doing was 3, 1. So that's 1. Then we come up here. 3, 1. So 31 in hex is encoded that way. The 2 is here. We actually did want to fuzz this one. Oops. So let's say that we want to find out what happens if we just let it keep going. This can be a little easier sometimes than the custom window if you want to roll the value. What we'll do here is say sequential, fuzz all of these bits, go for it. And you can see that we started sending data here. Speed this up just kind of so we can see what's going on. And when we hit the end, it incremented automatically up. We're sequentially going up through all of the bits that we said we wanted to fuzz. So if we want to try every bit pattern in a specific set of bits, you can do that easily with this fuzzing window. I'll turn this way up here. We can kind of see. Now, if I auto scroll, you can see that both of these bytes are going up pretty rapidly. And if I let it run long enough, you'd see it would get into the 3rd byte, then the 4th byte, then the 5th byte. It would continue to increment upward and upward through all these bits that we had set. Now, if I didn't want some of these set, I can change this while we're going. And we can go through less bits here. If you knew that, say, certain bits on the bus weren't necessary, or you already knew what they did, so you don't want to test them, we can turn those off and we won't fuzz them. Now we'll be going through bits much faster because I've taken it down by about half. So we're now much more rapidly shooting through the list of bits that I have set that we want to fuzz. So you can use that for a variety of different patterns. An interesting one you might do here, we'll try sweep and turn this way down. We'll do exactly what it says. Now you can see that we are sweeping through every bit that I said I wanted set. So if I turned these all back on, you can see that we are sweeping through every possible bit one at a time. So that's a good way to test if you're pretty sure that a given ID does control something but you don't know what bits do what. The fastest way to find that would be to say turn your inner frame space really slow. Now when this happens, you're setting a new bit once every 4 seconds. So you can watch what your vehicle does as these bits very slowly change. And let's say you're pretty sure that, say, this message controls door locks. Well, you might just get lucky, and if you sweep, you might find the bit that locks the door or unlocks the door by a slow sweep through the bits. It's not always that simple, but it could be that simple in certain vehicles. So that's a possible technique. You can sweep through the bits. Not probably quite so useful, but it exists as random bit scanning, With this, you can just plain spray out random bits from this and just find out what your devices do when they get random values in some of these bytes. It's maybe a little faster way to scatter shot and figure out what kind of crazy things you can make a vehicle do. But it's potentially dangerous as well. But this is how the fuzzing window works. It's, you can change these bits on the fly. You can't change bit scanning on the fly. So if you want to change from, say, random, sweep, or sequential, you've got to stop, change this, then go back in here. But this is useful for a variety of fuzzing tasks. I could have made different IDs in here, which you could then also randomly or sequentially scan. We can also take a list of all the frames that you've had on the bus and select the IDs from the frame list. All kinds of options there for trying to randomly or sequentially or sweep send bits to the bus. So that's the second most complicated way that you can go about all these things. The most complicated but most freeform and most powerful method is the scripting interface here. The scripting interface uses JavaScript. So I'll go here a second. Let's see. Load an example file. You should have these if you've got the program, if you download the binary, or even if you have if you download it from GitHub. In the examples folder here, you should have these. We'll load up get, can, and tick. Now we don't need all this stuff. I'm going to move this out. We don't need this filter. But once again, I will go through an example of how you can do the exact same thing here that we did before. So we're going to go over here, set up our array. We don't need this example script thing, but we'll leave it there. I'll set the interval for the tick to be 1,000 milliseconds. So once per second, we will call our tick function down here. Now, what we can do here is basically any normal JavaScript function. So I can say data 2 equals data 2 plus 1. Then send. So we will clear this out here so we can see. Recompile. I forgot to change. Just for completeness, we'll switch this here to be the exact same setup that we had before, so we send the exact same system. So here, once per second, we're doing the same thing we did before, sending on 7E0 to hexadecimal 31, and then an ever increasing byte in the third byte. So that's the same thing we did in the other two windows, but this time we're doing it with JavaScript. And we have much more control here. Now let's say that I knew that the 6th or the 7th byte is a counter, and the counter is only 16 long. And we knew that there was a security byte at the end that was, let's say a security byte's the sum of all the other bytes. So we'll go and further we'll say that that security byte always starts out as AA. So now we recompile there, run our JavaScript, and now we have what we have is that I forgot to put the +1 in there. There. So now we have a counter going in this byte. We have our security byte here that we calculated with our really lame security byte calculation. And we're sequentially increasing this to find out what happens. So now with the script interface, I can put counters in there. I can put security byte calculations in there. We can do all kinds of things that would have been difficult or impossible to do in the other windows. In here, the sky's the limit. Pretty much anything you can write in JavaScript, you can do. So much more possibilities for how you can generate your fuzz data if you do it in JavaScript. This kind of lets you bring in, you could probably even pretty easily port over other people's JavaScript functions that they used on other systems and use the SavvyCAN's underlying bus system for sending and receiving CAN. This only scratches the surface. The scripting window also supports ISO-TP and UDS sending a little more directly. You can see that in the help file. But this is how you would do it with just raw CAN frames, which quite often will be just fine. I can even show here, like I said, you can do all kinds of JavaScript functions. So if I recompile this, now we have what looks to be at least a little bit more accurately a security byte. It doesn't look quite as random, though we could even come in here, do even crazier stuff. Now we have a much more random looking, not terribly, but I'm just kind of off the cuff doing functions. So that's not a really great or random function, but it's something, and it kind of shows that you could do a variety of JavaScript functionality. I could come up here. Chances are if you're doing this for real, you're not going to want to send so slowly. So here we go for much more quickly trying out all of our bytes here with a 16 position counter and a security byte. So this is quite a powerful method. For people who are used to JavaScript, this is probably your fastest, easiest approach. You can easily see what your data bytes are here. You can easily work with them. You can see your interval here. It's all very straightforward, but it could also be a little more complicated to get into for people who aren't used to JavaScript. So you have a variety of options for fuzzing. Those are the three easiest options, and hopefully this has helped you out.